Hello and good day. Our lesson today is all about converting a number system, particularly binary number system, to decimal number system. I am Joseph F. Morco from Bicol Regional Science High School and welcome to my lesson. What is a number system? Previously in our lesson video, we talked about number system, that it is a technique to represent numbers in the computer architecture, in the computer system, that every value that you are saving, every text that you are saving, every graphics that you see or getting into or from a computer memory has a defined number system. We also talk about the different number systems in electronics, namely binary number system that is composed of only two digits, the ones and zeros. That is a base 2 number system. Also, octal number system is the base 8 number system and uses the digits 0 and 7. We also talk about a number system which uses digits from 0 to 9 to represent a number with base 10, and that is a decimal number system. Lastly, the hexadecimal number systems describes a base 16, remember? Base 16 number system. Now, for today's lesson, our objective is in order for the students to recognize a binary number system. What is a binary number system? And explain binary number system. Lastly, to convert, of course, our last objective today is to convert a number system to a decimal number system. So how are you going to do that? Stay tuned in this lesson. Binary number system is considered as the simplest number system that uses positional notation. That is, according to Merriam-Webster.com, it is a system. A positional notation is a system of expressing numbers in which digits are arranged in succession, one after the other. In binary system, there are only two symbols. I hope you already know what that two symbols are. They are zeros and 1. That is a binary. That is why it is called binary, bi. This base 2 system can be used to represent any quantity that can be represented in decimal or other number systems. So therefore, our binary number system, which is zeros and 1, has its representation in the other number system. So you name it, other number system. We have the octal number system. We have the decimal number system. We also have the hexadecimal number system. Therefore, a binary number system has its representation in the other number system. And that's what we are going to do now, to know the representation of the binary number system in different number system, particularly a decimal number system. And each binary digit has its own value or weight expressed as the powers of 2. Remember, each digit, that is what? That is each zeros and each 1 of the binary system has its own weight, okay? Has its own representation, has its own expression in the powers of 2. Now, in the binary number system, the following are the equivalents of the powers of 2 or the binary to the decimal number system. And what is that? There you have it. We have these numbers here. What does it mean? We all know that the binary is composed of only two digits, that is, ones and zeros, and it is a base 2 number system. Now the first one is 2 to the power of 0, which is the first bit of the system. Remember, we always start with 0. Now, 2 to the power of 0, the equivalent of that, that is the first bit of the binary number system, and the equivalent of that in the decimal number system is 1. Okay, we have here the 1, that is 1 base 10, meaning to say the base 10 here is representation of this number, meaning to say that this number is a decimal number. Why? Because it has a base of 10. Okay? So the next one, we have 2 to the powers of 1, and the representation and the equivalent of that in decimal is 2. Okay? So when you compute using an ordinary mathematical operation, 2 to the powers of 1 is equivalent to 2. And the next one is 2 to the powers of 2, that is, of course, that is 4 in decimal number system. So with the 2 to the powers of 3, okay, that is the equivalent of the 2 to the powers of 3 in decimal, it is 8. Why? Because we have 2 times 2 equals 4. Another times 2 again equals 8. Okay? The next one is we have 2 to the powers of 4. Of course, the equivalent of that in decimal system is 16. So with the next one, 2 to the powers of 5, it is 32. 2 times 2 times 2 times 2 times 2, that becomes 32. And also, we have 2 to the 6th, which is 64, 2 to the power of 7, which is 128, 2 to the powers of 8, that is 2506, and 2 to the powers of 9, that is 512. And we have also 2 to the powers of 10, that is 1024 or 1024, and so on. Binary number size. What does this mean? Binary numbers are also referred to as binary words. Therefore, each word has its representation in a form of a bit. Okay? Each word has a representation in binary in a form of a bit. Now, an 8-bit, remember, an 8-bit number is also an 8-bit word. It does not necessarily mean that that word is a single word or composed of a single word that is composed of a few letters, or a single word that is composed of more letters. The number of bits in a word determine the number of discrete states that can exist and the maximum number value that can be represented. So there you have it. Now let's proceed to the next slide. That is the binary decimal representation equivalence for a 4-bit. Remember, 4 bits word. So with 4 bits, the maximum possible number is 111. 4, or the decimal number 15. So what this table is all about. Let's touch this one by one. So this one here are the binary representation in a form of a bit. We have the first bit, second, third, and fourth bit. Okay? Binary counting. So in decimal, we count from 0, next to 0 is 1, next to 1 is 2, next to 2 is 3. Now, in binary, how do we count in binary? Remember that this table here is a representation equivalent of a 4-bit word. Remember, 4-bit word, only 4-bit word. So how do you count that one? Now, let's compare the difference between counting binary and counting decimal. So in this table here, we have counting decimal. As I have told you earlier, in decimal number system, we count from 0, followed by 1, followed by 2, followed by 3, followed by 4, followed by 5, and so on and so forth. How do we count binary? Okay? So in a 4-bit word, we have first, second, third, fourth. Okay? The equivalent of 0 in decimal is 0, 0, 0, 0 in binary. What about 1? The equivalent of 1 is in binary 0, 0, 0, 1. What about 2? The equivalent of 2 is 0, 0, 1, 0. Take note of that. Take note of that. Take note of the series. What about 3? The equivalent of 3 is the decimal, and here is the binary. What is the binary representation of 3? That is 0, 0, 1, 1. Okay? Or, since this is a 4-bit word, that is why we are obliged to say that it is 0, 0, 1, 1. What about the 4? 4 is 4 is 0, 1, 0, 0. And 5 is 0, 1, 0, 1. Okay, later we're going to demonstrate why is this so. Okay, so to continue, let's proceed to the next slide. What about 8? The 8 is 1, 0, 0, 0. Okay, what about the 9? You have 1, 0, 0, 1. And proceed with the 15, we have 1, 1, 1, 1. Okay, now here's the trick. Okay, here is the trick. I'm going to demonstrate how did we arrive at that one using a whiteboard. Now let's proceed. Converting binary to decimal. How do you convert binary to decimal? So let's take a look at this example here. Okay? First example is, how do you convert 1, 1, 1, 0 to decimal? This 1110 here is a binary number. You convert that into decimal. How do you do that? What you need to do is write down the binary numbers from right to left. Okay? You get the binary numbers, which is 1110, from right to left. So how are you going to get that? 0, 1, 1, 1. Okay? And write it down vertically. Okay? Write it down vertically. So that is why we have here 0. This 0 here came from this one. Okay? Now that you have all the zeros and ones written, okay, vertically, you are going to multiply each digit by 2 to the powers of, you will start with 0 power. That is why we multiplied 0 times 2 to the power of 0. The next one, we are going to multiply 1 times 2 to the powers of 1. Okay? Because next to 0 is 1. Okay? Because this is what? The 1 here is the second bit. Therefore, we are going to multiply it by 2 to the powers of 1, because 1 is the second bit. Remember, we always start counting in bits with 0. Okay, that is why the second power here is 1 and not 2. Remember? Okay, because we started the first bit with 0. Okay, the next one is, we have 1 here, and we are going to multiply that with 2 by, why are you going to multiply that with 2? Because it is a binary. Okay? So remember, take note that in converting binary to decimal, you just have to multiply that to what? To 2. Because binary is base 2. Okay? So, proceed to this one. This one will be multiplied to 2 to the powers of 2. Because this one here is the third bit. Okay? And the last bit or the fourth bit here is to be multiplied by 2 to the powers of 3 as its fourth bit. Now that we have that equation here, you just need to multiply that. Do the proper mathematical conversion or solution or solving this one. So that is why we arrived at this one here. 0 times 2 to the powers of 0 is equals to 0. And 1 times 2 to the powers of 1 is equals to 2. 1 times 2 to the powers of 2 is equals to 4. And 1 times 2 to the powers of 3, that is equals to 8. And the next thing that we are going to do is what? We're going to add all the results. 0 plus 2 plus 4 plus 8, that becomes 14. So that is why 1110 is equivalent to 14 in decimal. Okay? So to check that one, I have a very good way of checking this one. Okay? We don't need to go anywhere. We don't need to ask somebody. Okay? We just have to go to the internet. How are we going to do that? Okay? Now, let's skip the next problem. So this slide here shows how do we check whether the answer in our binary to decimal conversion is correct or not. So just go to this web address here, the website. We have a lot of sites on how to convert binary system and so on and so forth. So in this one, I've used rapidtables.com to convert binary to decimal. So as you can see, in here, I just type 1110 and convert. So the result is 14. Okay? The result is 14. So earlier part of this lesson, we are told of a 4-bit word in binary. Okay? So we're going to base our answer in this table. Okay? In this table. So we're going to have, since this is a binary, we're going to have 1, 2, 4, and 8. Now, where did it came from? It came from 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. Okay? That's it. Now, let's have this one. Okay, 0, 0, 1, 0. What is the equivalent in decimal? The trick is, you just have to what? You just have to disregard zeros. All you need to do and remember is the 1, the location of 1. Where is 1 located? 1 is located here. That is why it is 2. No more. 0, you don't need to count because that is already 0. 0 and 0. What about this one? 1, 1, 0, 1. What is the equivalent of that in decimal? Okay, remember, disregard the 0. Only get the location of 1. Now, the 1 here is located in the 8. So therefore, we're going to write 8. And the 1 here is located here in the 4. So we are going to write 4. The 0 is located in the 2. That is 0. Disregard that 1. And the 1 is located here. We're going to have 1. And add all of those things. 8 plus 4 is equals 12. Plus 1 is equals 13. That is why this one here is equals to 13. Okay, what about this one? 1, 0, 1, 1. Okay, what about that one? 1, 0, 1, 1. 1 is in 8. 0, disregard. Another one is in 2. Another one is in 1. Okay? So you add all of those things. 8 plus 2, 10 plus 1, that is 11. That is why this is 11. Okay? That is 11. You get it? Another one. 0, 1, 1, 1. What's the equivalent? Now, 0 disregard. 1 is in the 4. Another one, 2. Another one, 1. That is, you add all of those things. 4 plus 2 is 6. Plus 1 is 7. That is why this is 7. Now let's check. Okay, or let's do the previous process that we earlier did. Wherein, what we're going to do is multiply by 2 to the powers of the bit. Okay? So, how am I going to do it? Okay, let's transfer this. Okay, let's just do it here. Okay? What about this one? 1, 1, 0, 1 equals what? In decimal. So, we're going to get this 1. Okay, this 1. 0, 0, 0, 1. This one here. And the other one. Okay. And we're going to multiply. No. Sorry. We're going to multiply that all by 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and 2 to the power of 3. So what's the answer? What's the answer? 2 to the 1 times 2 to the power of 0 is, that is 1. What about 0? That is already 0. Because any number multiplied by 0 is 0. Now, sorry. 1 times 2 to the power of 2, that is, what is that? That is, okay? That is 4, right? And this one is 2 to the power of 3, that is 8. Now, we're going to add all of those things. 1 plus 4, 5, plus 8, we have 13, base 10. So, do we have the same number here? Yes, we have the same number. So, we have the manual process. We have our previously known process. Another one. Another one. What about this one here? What about this one here? Okay. 1, 1. No. 1, 0, 1, 1 is equals to what? So, get these digits here, the binary, from right to left, downward. Okay? Right to left, downward. Okay? So, therefore, 1, 1, 0, 1 times 2 to the power of 0 times 2 to the power of 1 times 2 to the power of 2 times 2 to the power of 3. This is equals to 1. This is equals to 2, right? This is equals to, of course, 0. And this is equals to 2 to the power of 3 is 8. Okay? So, you add all of those things. 1 plus 2 is 3 plus 8 is equals to 11 base 10. So, do you have the same number? Do you have the same result? Yes, you have the same result. Okay, I'm sorry. Okay, I'm sorry. Okay, you have the same result. So I hope that is clear. Okay, so the next slide will be your task. So since you already know how to convert binary to decimal, and this is very simple. Okay, let's have a self check. Okay, I want you to do the following test review on your own. Okay, do it. Okay, what are the problem? Okay, so here are the problems. Convert the following binary numbers to decimal number system. Okay, I'm going to give you maybe 5 minutes. Is that good? No? Okay, I'll give you maybe 6 minutes. Okay, 6 minutes for that. Your turn is on. See you soon. Okay, I'm going to check your answer. Hello, I'm back. I hope you are doing well with your problem. So now, let's check whether your answer is correct. Okay? In order to check that, what we're going to do is we will be using the what? A website to check whether your answer is correct. Okay? So we'll go to www.rapidtables.com. Okay? Stay tuned. Okay, I'm going to open my browser. Okay, hello once again. Using a browser, let's open rapidtables.com and use this website to convert or to check whether our answer in converting binary to decimal is correct. So we don't need to do the manual thing to convert or to check whether our answer is right. So let's convert what's the equivalent in decimal of 1101. Let's try to convert. That is 13. Okay, let's write here. That is 13. I hope your answer is correct. What about the next one? 111011. Convert. That is 59. Okay? 59. I hope you get it correct. What about the next one? 11000011. Let's convert using this tool. That is 99. Okay? So, did you do well on your exercise? The fourth one is 10111. Let's convert. The answer is 23. I hope you did it right. The last one is 10101. Let's convert, and the answer is 21. I hope you got it all correct. Okay? Thank you.